Kicking off our chapter on conics. Conics is the study of what happens when we take this cone shape that you see in red and we slice it in different ways. And the first one we're going to study is the parabola. So when we cut the cone at an angle, we get a parabola shape like we've studied previously. And we've taken a look before at this format for a parabola right here, this equation, right? H and K control the vertex. And a big part of this chapter is going to be anything that you see in parentheses because it says x minus h. The h value is actually going to be the opposite of the number that you see. So that should be fairly familiar to you. The a value out front controls the opening, whether it opens up or down. A positive a value gives you a smiley, happy, upward opening parabola, and a negative a value gives you a frowny, mad, downward opening parabola. The new part of this is going to be the x equals equation, and that is going to give you a parabola that opens left to right. Notice that the h and k values are flipped. K is now on the inside of the parentheses and h is on the outside. K is subtracted, so the k value is going to be the opposite of what you see. Either way, the vertex is going to be h comma k. So looking at this first example, we have an a value of 2 from right here. My h value, since it's an x y equals equation with x on the right side, my h value is attached to x, so that is going to be an opposite because it's in the parentheses, and I have a k value of 4. So my vertex is going to be at 3 comma 4. And so over 3 up 4. And the general shape of this is going to be a happy upward opening parabola. We could use Desmos or RTIs to get some more accurate data. But I want you to get this concept of getting the vertex from this equation and determining the opening. For part B, we have a value of 2. My h value now is out here because this is an x equals equation. So it's going to be y minus k. So my k value is 3. My h value is 4. And my vertex is still h comma k. So over 4 up 3. Now, because this is an x equals equation, it is going to open left to right. And we can graph that in Desmos, where we cannot graph that on our TI-83s because those don't work with the x equals equations. So I can just type that in. Y minus 3 squared plus 4. And we see this sideways parabola laying on its side. Not a very good sketch there by me, but right, we see it opening this way because it's x equals. A positive a value means the opening is going to be to the right. For example 2, all we are doing is looking at identifying a, h, and k. For both of them, the a value is always out in front of the parentheses. Part A is a y equals equation, so your h value is inside the parentheses with x, and it is going to be the opposite value of what you see because the generic formula is x minus h. So to get a subtracting of 4 in there, we have an h value of positive 4 and a k value of 5. Always h comma k for your vertex. For part B, it's an x equals equation, which means my k value is attached to the y inside the parentheses, and is opposite. Okay, so this one has a vertex at -2, -7. So when we are doing some graphing with these, um, same things apply. We have a y equals equation. So my h value is inside the parentheses with x. So I am going to have a vertex at -4, -1. -4, -1. There's my vertex. If I want some data, for these, it's actually easier to go into the TI-83, but that's going to fail me then in the next example when I'm looking at an x equals equation. So let's type this in real quick. -3 times x plus 4 squared minus 1. So I can add a table of values by clicking into my equation and then hit the gear, and then I hit the table. And then this gives me a set of values here to that I can use to graph. So I'm going to have to re-enter these though, so that I'm working on both sides of the vertex. And so I have my values there. I can see then that I can use the -5, -4 point, and the -3, -4 point. And that's about it. The rest of them are not going to be on my screen. Um, Not a very good graph there, but you get the idea of graphing this parabola. For an x equals parabola, I have a value of 3. Now nothing is getting added or subtracted to the y before I square it, so it has a k value of 0. It has an h value of 1. So I am going to have a vertex there at 1, 0. When I graph this, x equals 3y squared plus 1. I see over on the far side of the screen my sideways opening parabola. And we are unable to make a table of values with Desmos in this x equals equation. The main thing I want you to recognize, though, is that this opens sideways. And the opening is going to be on the right because it is positive. We could enter some values of y on our own, right? So a -1 squared entering in is 1 times 3 is 3 plus 1 is 4. So this would also be 4. So 4 comma 1 should have a point here, and 4 comma -1. And we could continue on with some other y values, right? We're using y now is our independent variable, which is a different thinking process than what we are used to. The TI-83 cannot build this graph because you cannot enter an x equals equation. So this chapter, we're going to be relying heavily on Desmos. You have an assignment then on identifying A, H, and K in some graphs, as well as some graphing.